Hey guys, design time again, and finally the third part of the high voltage helium neon laser power supply that I designed. This time we'll show you how it works using three different laser tubes that I have here. First of all, a small one, bigger one, and this large one. As I said before, this video is sponsored by PCBWay. The PCBs are kindly sponsored by PCBWay, and I will project the laser on the PCBWay box. It's very nice and white, so you can see it very good. This is how the setup looks. Power supply itself. We've connected the ground, and blue and red go to the multimeter. This goes through the meter circuit that is 100,000 to 1. That means 20 kilovolts are 200 millivolts. Then we have the 12 volt PSU. This is this one I will use. And of course the output, the high voltage output, that goes through a ballast resistor that is needed if it is not already in an enclosure like that, directed to the plus, to the anode of the laser tube itself, and the minus, the ground, going to the ground of the high voltage. So let's see what happens. Yeah, but we don't let it like that. Let's turn off the light. Look at that. Look at that. Look at that light. Like a devil. And here we have the point. I think the optics of the... Yeah, I can use it a little bit. Let's let it down again. The optics of this tube are, I think, a little bit a problem, because I see a second dot, but anyway. Let's go back, the zoom. We have 12 volts. Look at that. Oh my God, I love it. So nice. I have to show it more to you, even with more rectification, with more zoom. Wow. The high voltage power supply, let's check if something getting warm. Nope. And we're supplying 1660 volt sustained voltage to this tube. It's a small one, a HeNe GLT 17991, and this is how it looks. I'm not touching the ballast resistor because there's high voltage. By the way, guys, if for any reasons you want to build this thing, be careful, and it's on your own risk. It will not kill you, but it will zap you bad. Okay, let's check the next larger one. For the next larger one, I don't have any data. I just experimentally find out the voltage and what it draws. And the point. Okay, and the next one. Okay, here we have the second tube. It's a much larger one. For example, here you can compare the tubes. Not getting too close to that. This is how it looks, really much smaller one. And let's take a look of it. This one has the electrodes on the other side. And again, PCB way dot. This one has a much better optic. PCB way. And sustained voltage is 2120 volts. It's higher, but it's normal because the tube is much larger. Look at this beautiful light that is emitted here. It is, I don't know, I love it. Look. Absolutely unnecessary equipment, because an LED diode is, not LED, laser diodes are the same wattage on this one, 5 milliwatts, that's nothing, but it looks so much better. And this is the power supply again, let's see if it gets warmer. Nope, this one gets warm, ballast resistor, but I'm not touching it. No touchy, because this will zap me. So, and look at that. I think now it's a good time to say, guys, if you like my videos, if you like my content, smash the like button, subscribe to my channel, please, and push the bell button so you can get notified when I have new content. This helps me, not me, helps my channel to grow and gives me the possibility to show you more interesting stuff like that and make more designs available for you. Okay, let's take the last one, that is a big one, big tube. Okay, the big Bertha now. Melgrio, Meligrio, I don't know how to pronounce it. You see? You can see nothing, but at the moment we have an open output. That means that the PSU is not triggered. We have to, this is why the output voltage is quite high, but it's not triggering. We have to raise the voltage a little bit. You can see it's trying, but now it's triggered. And we have 3200 volts sustained voltage. Look at that nice point. Of course it's too near everything, so the point is too big, but you don't see many things here because this thing is completely closed. I don't want to go too near to the hot output part. This is the biggest one I have. Just for you to see what it says, it's 10 milliwatts and 600, what does it say? 632.8 nanometers. That's a professional one. Again, the power supply. Now, of course, the things are getting a little warmer. Yeah. Because we are at 10 milliwatts, and let's not forget the CCFL is only a 12 watt CCFL that goes absolute maximum to 10 milliamps. This one goes to 6 milliamps. So it's starting to get warm, everything here now. But this is how it looks. 3,240 volts. At almost 12 volts, you can go up to 15 volts, but then you are reaching the limits of this power supply. Both, you have to put you have to cool the regulator, the Buck regulator down, and you're reaching the limits of the transistors and everything. It's good up to a 10 watt laser tube. You look at that. But this one is not the most spectacular, but the most powerful one. So, thank you again, PCBWay. You get a big red dot. Thank you for the nice PCBs. And again, PCBWay is the sponsor of this video that made it possible to show you this juicy high voltage power supply. It can zap you, really hard. You will feel it will hurt a lot, yeah? You know, this resistor, what you see there, it's in a high voltage, 10 kilovolt. We are 10, I think, yeah? 5.6, no, it's a 2.4 mega ohm. If you make this resistor smaller, and these capacitors of the Cockcroft-Walton multiplier larger, you will have really sparks that probably could kill you too. It's quite a lot of current that you produce. I had this one instead of 2.4 megs, I had it worth 400 kilo ohms, and it started to make popping noise, loud popping noise everywhere. That I have the high voltage soldering as round, as smooth as possible. This would not work without putting in the whole thing in an transformer oil or potting it. It will produce up to 20 kilovolts, and this is loud. Okay guys, that's it for today. That was the third part of the video. Hope you like it. Cheers, and see you next time, hopefully. Bye.